A very good afternoon, students. In this video, we will be discussing the constraint satisfaction topic, which is a part of Unit A or Section A of the syllabus. In constraint satisfaction, what we have to do is we have to solve a problem, and in that problem, we have some information about various facts, and using that information, we have to calculate some values. And when we calculate those values, we have to make an estimation, and then we have to check whether the estimate that we made, it is violating some of the constraints or some of the properties which we decided earlier. For example, let me explain this with a proper example, then it will be more clear. We have the crypt arithmetic problem. Okay, it is given here, example is given here. Suppose you have this message that you want to send through a telegram, send more money. Now, in this if you will send this message as it is, then anybody can read this message. So what we want to do is we want to encrypt this message. So for encryption purpose, what we will do, we will assign some codes to each of the alphabets and convert that character message into a numeric message. Now, how we will assign characters? If we go by simple law, then we can assign 1 to A, B, 2 to B, 3 to C, and like that we can make some arrangement. But in that case, this message will become more understandable. What we want is we should assign a digit, only a single digit to each of these characters. That is, our limit is from 0 to 9. We have to assign the characters to each of these digits to each of these characters. And then we have to ensure that whatever value we assign to S and M, that should result in MO. Whatever value I assign to D, when I add that value with the value of E, I should get the value of Y. This is what we want to ensure, so that it looks like an arithmetic sum, and it is an encryption method. So how we will do it? Now we can start from either of the ends, but let us start from the left hand side. On the left hand side, we have S and M. Now there are 4 characters in the first number, there are 4 characters in the second number, but there are 5 characters in the third value. Now that means when S and M are added, there was a carry generated, because of which this M is getting generated. Now, since we have to assign the values from 0 to 9, say either of S or M is 9 and another one is 8. So we assign the highest values to both of them. In that case, 9 plus 8 will give you a 17. That means maximum value that this M can have is 1. Now, since this is 1, this also has to be 1. Now, that means S is added to 1 to generate this carry of 1 over here. Now, either S is 9 or S is 8, and there was a carry from the previous state. Now, if S is 9, then we have 9 plus 1, 10. And if this is 8, we have 1 from the carry of the previous state. So 1 plus 8 plus 1 will give us a 10. So we fix the values here. M is 1. Here also M is 1. O is 0. O is 0 here. And S is 9 or 8. Now, if we add E with 0, then N should get generated. Now the question arises, since O is 0, so when E is added to 0, same number will get generated, but this is a different number. That means there was a carry from the previous state, and that was added to E, and then we got N. Another thing is, since 9 or 8 is to be fixed with S, since we are adding something into 0, even if this number is 9 and we add a 1 to it, so in order to generate the carry, so let us say S can be 8 or 9 and E is something added into 0 which generates N. That means there was a carry from the previous state. Similarly, we can have here now N and R are added and they should generate a carry, and this E and this E should match. So this way we move one by one step ahead and we try to assign values to each of the characters so that finally we have some set of values. So in constraint satisfaction, the goal is to discover some problem state that satisfies a given set of constraints and solve those set of constraints. So the algorithm for doing this is, first of all, whatever constraints are available to us, we will try to strengthen them. That is, we will try to write them clearly at one place, and we will check that there is no inconsistency in the already available state of each of the constraints. Then we will select one open constraint for which we want to find out the value, and we call it OB, and then we try to strengthen this constraint from whatever knowledge we have. Now, after we strengthen or find the value of this OB, we add the value of OB to our all open constraints. Then we will remove OB from open and we will go back to the previous state. Again, we will select one constraint and we will try to solve its value. After the value is fixed, we will again try to go back and again we will check for inconsistency. If inconsistency is not there, we will try to solve all the goals or all the constraints. After we have performed for all the open OBs and there is no open OB left, in that case we will first check that the union of all the values that we have found, it is generating the solution. Then we will return and quit. If it is not generating a solution, it is generating some kind of a contradiction, whatever estimation we have made, we will return a failure. So what we are doing here, first we select the group of open constraints and one by one for each of the constraints we will try to find the value. Then after all the constraints have been solved, we try to put them together, check for inconsistency or contradiction. If contradiction is not there, solution is reported. Otherwise, the contradiction is reported. Thank you.